All right, welcome to this explainer. Today, we're going to build a totally clear, structured mental model of AWS serverless technologies. Whether you're designing a real-world architecture from scratch, or you're just grinding away studying for that solutions architect exam, this is exactly the breakdown you need. We're going to see exactly how these individual AWS tools just snap together, like a giant puzzle, to create incredibly powerful, globally scalable applications. And the best part? We do all of this without ever having to touch a single piece of hardware.
But first, let's tackle the absolute biggest myth in cloud computing right up front. When people hear the term serverless, the immediate logical question is, wait, if there are no servers, is my code just kind of magically floating out there in the cloud? Okay, spoiler alert, there are absolutely still servers, but in this computing paradigm, you as the developer just don't have to manage, provision, or patch them. You literally just deploy your code, AWS takes over, finds the physical hardware, allocates the resources, and makes sure it runs. Your only job is writing the business logic. That's the real magic here.
So here's our roadmap for this explainer. 1. The serverless paradigm. 2. Lambda, the compute engine. 3. Computing at the edge. 4. DynamoDB, serverless database. And 5. Connecting the pieces.
All right, part 1. The serverless paradigm, beyond just functions. You know, serverless kind of started with AWS Lambda. It was this whole functions as a service vibe, where you wrote a script and it just ran. But wow, has it evolved since then. It has exploded into this massive ecosystem. We're talking managed databases like DynamoDB, routing with API Gateway, storage with S3, and even messaging and authentication. And they all operate under that exact same golden rule. You do not manage the underlying hardware.
Moving into part 2, Lambda, the compute engine. Pay exactly for what you use.
So let's contrast this with traditional EC2 servers. Think about an EC2 instance. You create a virtual server, assign it specific RAM and CPU, and then it just runs continuously. Even if literally no one is using your app at 3 a.m., that server sits there idle, burning your money, and you have to manually tell it how to scale. Lambda, on the other hand, it's built for short executions. It runs strictly on demand, only when triggered, and it scales completely automatically. You are charged solely for the exact fraction of compute time your code runs. To put that cost-effectiveness into perspective, AWS literally gives you 1 million free Lambda requests per month on their free tier. Plus, you get 400,000 gigabyte seconds of free compute time. I mean, that means you can build and test incredibly robust architectures with basically zero upfront cost. It's a total game changer. Now, if you're gearing up for the Solutions Architect exam, pay close attention. These are the hard limits you absolutely need to have memorized. Lambda isn't for hours-long data crunching. The maximum execution time is strictly 15 minutes. That's 900 seconds. Memory scales from 128 megabytes up to 10 gigabytes. And here's the cool part. As you crank up the memory, AWS automatically improves your CPU and network allocation too. Your deployment package can't exceed 50 megabytes compressed. Oh, and a great pro tip, you can use the /temp directory to cache startup files, which drastically speeds up your function's cold start times.
Here's a fun quirk though. By default, a Lambda function launches out in the wild outside your custom network. It has access to the public internet, sure, but it cannot see into your private network. So if you needed to securely talk to, say, a private relational database, you have to attach it to your virtual private cloud, or VPC. To do this, you define the VPC ID, the subnets, and the security groups. Once you feed that in, AWS automatically creates an elastic network interface, an ENI, which basically acts as a secure bridge into your private resources.
Which brings us to Section 3, Computing at the Edge, pushing logic closer to the user. Picture this. A user in Tokyo hits an edge location for your app. You obviously want to serve them incredibly fast. You've got two main serverless tools here, and you have to decide if you just need a lightweight tweak to the viewer's request or if you need some heavy-duty origin manipulation. CloudFront functions are lightning fast but pretty limited. They only touch the immediate viewer request and response. Lambda at edge, though, way more powerful. It can alter the request before it ever reaches your main server, the origin, and it handles heavy logic, like external network calls. This right here, this is your exam critical decision matrix. If you just need sub-millisecond URL redirects or maybe some quick header manipulation, CloudFront Functions is your highly cost-effective winner. I mean, it's 1/6 the price. But if you need Python support, gigabytes of RAM, or execution times up to 10 seconds, maybe to authorize a user against the database before serving content, then you absolutely must use Lambda at it.
All right, Part 4, DynamoDB, serverless database, highly available, NoSQL scaling. Forget rigid relational databases for a second, the ones where you have to define every single column before writing a line of code. DynamoDB is NoSQL. It lets you have a rapidly evolving, flexible schema where individual items can be up to 400 kilobytes. The only strict rule you've got is defining your primary key structure up front when you create the table. That could just be a unique partition key or a composite of a partition key plus a sort key. That's what lets you highly optimize how you query and organize all that data. When you're setting this up, you've got to ask yourself one major question. Do I know exactly how much traffic my database is going to get? Because your answer dictates which of these two capacity modes will save you from either bad latency or a terrible build. If your traffic is super predictable, stick to provisioned mode. You set fixed read and write capacity units, and it's way cheaper per request. But if your app is totally unpredictable and might literally go viral overnight, choose on-demand mode. It instantly auto-scales to handle massive traffic spikes. You pay exactly for what you use, even though the per-request rate is slightly higher. But wait, what happens if your app gets too popular? If your DynamoDB reads are getting seriously congested, DAX, the DynamoDB Accelerator, is your plug-and-play lifesaver. It's a fully managed in-memory cache exclusively for DynamoDB, and it gives you microsecond latency without touching a single line of your application logic. Elasticache on the flip side is a general-purpose cache, really flexible, great for session data, but it requires heavy code changes and manual server management to implement.
Now for data analytics. Say you need to fire off a real-time Lambda alert every single time a new user registers in your database. DynamoDB Streams will capture that exact item-level change and keep a log of it for 24 hours. Perfect. But if you need to pipeline that data into a massive analytics warehouse with heavy processing and up to a 1-year retention period, you're definitely going to want to use Kinesis data streams instead. Okay, the final stretch. Part 5, connecting the pieces, routing and orchestration.
Think of API Gateway as the ultimate bouncer and traffic cop for your microservices. It sits right there between your clients and your backend. Instead of exposing your Lambda functions directly to the wild internet, API Gateway safely routes the traffic. It manages throttling limits to prevent abuse, handles API versioning like V1 versus V2, and does it all without you lifting a finger. It even links up with Amazon Cognito to authenticate external users before they ever get near your database. When deploying that API Gateway, you've got 3 endpoint types to choose from. Private is just for your internal network. Regional is for users located geographically close to your deployment. But here is an absolutely crucial tip for the exam. If you deploy an edge-optimized API to serve global users through CloudFront, your HTTPS security TLS certificate absolutely must be housed in the US East 1 region. Doesn't matter where the API gateway actually lives, that certificate goes in US East 1. So, what if your application isn't just a simple request, but a massive multi-step e-commerce checkout process? When your architecture gets too complex for a single Lambda function, Step Function steps in. It's a visual orchestrator that seamlessly chains multiple AWS services together. It handles the logic, evaluates variables, and check this out, it can even pause the entire workflow to wait for a human manager to click an approve button via email before firing off the final Lambda function. So we've totally shattered the myth of serverless today. We've built a complete, highly scalable, modular toolkit right here. By chaining together API Gateway, Lambda, and DynamoDB, we've stripped away all the heavy lifting of traditional IT. Which really leaves us with one final, fascinating thought. What incredible, globally scalable applications will you build when infrastructure is completely out of your way?